Okay, what's next in the pile over here? This one's a lot lighter. This might be an aluminum head. Maybe it's a pan head. Who knows? Never know until you open them. Oh, this is airplane parts. Yep, airplane parts. Pistons. Big ass pistons. Alright, I've been waiting for these for a while. There we go. Yeah, I'll keep it. Okay, so what do we got here? There's our part number. Item also listed on eBay. Oh, that's nice. There's another part number. I think this is the part number. Oh, that's the same number they wrote there. No, that has a 2 or a 3. This has a 0. Different part number. So I don't know what the difference is. I don't know. Something. And then this one over here. That looks like the original number. So this is a genuine Continental. Good, it's a Continental motor. So this has a little bit of a big bore piston here. So this is your normal Harley piston here. So this is a standard big twin Evo high compression piston. This is big bore. This is bigger big bore. See, a little different. Makes it look like a 45 motor. So there we go. That's slightly bigger than stock. So that fits Mr. Airplane motor over here that we're working on. That's the small bore airplane motor. This big bore airplane motor right here. That's what this one is. So this has a small bore in it. Put your hand in there, no problem. So that's what this is for. Boom, it fit right in there. Appears to be a little bit looser than it's supposed to be. Probably not the right size. I'm guessing this is probably standard, and this is not. So let's see what size these are. Where's my other airplane motor at? Here's my other airplane piston. Just a small bore motor. Big bore motor. 3/4 inch different. There you go. So now let's see what we got here. This thing is 5.240. So standard bore is 250. So these are 10 thousandths piston clearance stock. Okay. So that's for a standard motor. This is not a standard motor. I can read it. .258. So that's 10 over. So I need a 10 over piston, not a standard piston. So these are 10 over cylinders. I thought they were like 20 or 30, but okay, so they're 10. Yeah, whatever. So this is standard. So it doesn't help me for using on that motor, but it helps me on using what I can see. Now, in order to use this motor, we have to know how much stroke you can put in there. You go all the way down like that. You measure from here to the top of your cylinder, and that's how much stroke you can have in these things. With a stock piston. So I'll take my 6-inch scale, bottom it out, go like that. Appears to be 4 inches. That's all you got. Now, as I recall, this motor is supposed to have a 4 1/8 inch stroke in this thing, so that means that piston is going to come out of the hole about that far, and I find that hard to believe the airplane motor would do that. So even though these are supposed to be all the same between the long stroke and short stroke motors, because it's 3 7/8 is the short stroke, 4 1/8 is the long stroke. I'm thinking there's something different because this would have to be sticking down deeper to allow more stroke. So someone's lying to me, basically what I'm going to say. I think it's heavy too. Okay, so the next thing I want to know is there a difference in compression height in these two motors? Yes, there is. About that much difference. It looks like the wrist pin's bigger. That was a 1-inch pin. This one here, I can't read it that way. Read it this way. Appears to be 1 1/8. I was told to use 1 1/8 inch pins, and this one measured in 1 inch. So oh well, so much for information. This one's 1 inch, 1 1/8. That's 1 inch. So small motor, big motor deal again. Okay, so that gives me a lot of ideas that what we got to work here with. That thing feels like it's at least 5/8 of an inch thick. It's thick. That is really, really thick in there. So if you want to know how much that is thick, we go like this. Zero that out. Flip it around. And see how much is sticking up above the top of the skirt there. It looks like about a 1/2 inch. This is a 1/2 inch tall. So we'll just stick that right on top of that. Like that. Put this on that. And see, it's another 1/8 inch more. It's 5/8 of an inch thick. There you go. I guessed pretty close, didn't I? That's what it felt like to me, was 5/8. Alright, so the piston is 5/8 down would be what? Okay, the piston is this thick. The bottom of this ring line is how thick that piston is on the inside. So that means you can cut a bunch off of that if you need to get some more room for stroke. Made in Brazil. That's where most of these pistons are coming from, is Brazil. Alright, well that's how you find out what you're getting. You have to buy them. What's this one? Oh, this is an old piston. Look at that. That's old. A new piston here. Okay, this has a steel ring groove in it here, which is your newer style. This one here is all aluminum. Other than that, they look very similar. They're definitely heavy. This one's a little bit thicker how it's cut in here. Looks like they both have multiple rings on there. Looks like they take the same rings, which are thick ass rings. These things are about 90 thou thick. Oop, we're not zeroed. Re-zero. 104 thou. So it's a 100 thou ring. That one's 90. And that's 194. Damn. Thick rings. 105 again. 90 again. And 192 again. Yep, same. These are all the same. So it takes the same rings. So it looks like the only thing they did different was they put the steel in here to make it stronger. Put the same holes in there for the oil coming out. So other than that, they look like the same thing. Early and late design is the same thing. So that obviously is the correct number there because that's the one on top of the piston. This one don't have a, oh, that has a number on it too. What is this one? It's hard to read it. It's a P14J 5P something. So I'm assuming the compression height is the same. Pistons are the same height. Skirt's the same height, so I'm sure they're the same identical piston other than that. But obviously this piston here is a lot smaller. About every way about it smaller. So there we go. So now I got some mock-ups. Now the piston skirt should probably be standard again, I bet. Yeah, pretty much. It's a thou or so bigger. So a little bit tighter fitting than the other one. Still nice and loose. Boom. There you go. Big ass bores. Now that's a V-twin motor there. Two of those in there. We got a V-twin motor. So. Here's the motor we're going to put it on. So that's my Sportster 4-cam motor. Got 4 cams, see? So if you take these 2 pistons and you put them on top of your motor here, you can see where you got to put your cylinders at to make everything clear. See, that's the problem. You got a lack of clearance. See how these two here are hitting each other? Look at the interference on those. You already see we're going to be all the way out to here, it looks like, at the cylinder location. Because right now they're over there. They're mating in there. You can't run them that way. So it looks like the sleeves will be back to here. And probably about 3/4 of his oil filter is where the cylinder is going to wind up being. Got to move out a little bit. So it's another reason why you want pistons and kind of get things in here and see how they're going to fit. See, even like that, they just don't. Nothing matches up. So we can probably lay them out here like that. And we can do that. See, flip these things over. Okay. Now, where you want to sit? Quit rolling, damn it. Yeah, I know how to make it quit rolling. You know how to make a piston quit rolling? You put something on the table that has drag on it. God, it's heavy. Like that. Get this hose out of the way. Boom. And this one goes here. Okay, so you mock those upright like that. There you go. How does that look? Looks pretty good to me. There you go. About that height there. The higher you go, the more clearance you get as you run your rods. But obviously the crank is not centered here, see? There's center. See your little offset. You're not supposed to do that. That ain't good. Yeah, it looks like we got about a 1-inch offset. That's about a 1-inch offset there. That's not. You're not supposed to do that. Yeah, it's not quite 1 inch. But it's a good. Yeah. That's probably about 3/4 of an inch difference. So back in the day, you run an offset wrist pin in your piston, and that would change your rod angle. And you can either lay it down more angle, or you can go straighter up and down for less piston slap. If you go more rod angle, it gets more power. That's when you put them in the backwards, old 350 Chevy stuff. So you would offset them 100th hour or so to gain power. Harley used to do 60 and 100 and 80 and 90. S&S used to dick around with that too, on moving the wrist pins around. They quit doing that. They just went back on center. But you can move these things over a little bit, but you're not supposed to move them over that far. Obviously, when you move them way the hell over, the piston weight gets kind of goofy. But with a big ass piston like this, you can get away with more than a normal motor. You know, if I move this thing over a 1/2 inch to here, that's what on a small piston. About the same thing as moving that over 1/8 of an inch. This way here, it's about the same difference as you go from here to here. You know, you're still off center on the relative spies. You can be over. You can probably go at least a 1/2 inch, and to equal what that would be about an 1/8 inch. So at least 3/8, probably 3/8. So it's a lot bigger piston. You can move more offset and get away with more crap. But anyway, this one here, we're going to do a lot of offsetting rod stuff, which, like I said, it's not something you really want to do, but if you don't do that, you can't do it. If you want this thing to be on center, then these things are going to be way the hell up here. See, now, you're going to way up high like that. your bores, you can see how now they're on center where they're supposed to be. Like that. Now they clear better. Alright, there you go.